So we looked at how to solve a quadratic function and find the zeros by graphing, and now we're going to solve by factoring. So we looked at how to solve by graphing, and whenever we graphed, we looked at where did our parabola cross the x-axis. And at those points, those were our zeros, right? Well, another method is to look at the related quadratic equation, okay? So here's a function. It's y equals, and then it's in terms of x over here. So that's a function, right? Well, the related quadratic equation is when I replace this y with a 0, and now I can solve for x. Now, why do I replace y with 0? Well, if you look over here at this parabola, these values are the zeros, right? Well, what is the value of y there? Well, y is also 0 at those points, okay? So I'm allowed to replace y with 0 here to solve. Now, whenever we're solving the equation, we call them solutions or roots. Now, when I'm looking at the graph, they're the zeros of the function. So just kind of touchy terminology here when we're talking about quadratics, but really when you see the words zeros, solutions, roots, they all pretty much mean the same thing. It's where does my graph hit the x-axis, where y is 0. Just to kind of refresh your memory, remember a quadratic equation, we've been looking at these guys, ax squared plus bx plus c, where a, b, and c are real numbers and a is not allowed to be 0. Now, we want to look at what does it mean when I have different types of roots or solutions. How does that relate to what the graph looks like? Well, if I'm going to have a parabola that hits the x-axis twice, I'm going to have two solutions or roots. Okay, and this could be up or down, or it could go this way. If it only hits once, which means that the vertex is sitting right there, then that means I only have one solution or root. Okay? And if it doesn't hit at all, that means I have no real solutions or no real roots. Okay, now remember that word there, real, is going to be important because that actually means I have imaginary solutions. So you have to state no real solutions. So to kind of sum up all of this vocabulary we've been looking at, the x values that make y equal 0, they're solutions to the quadratic equation. They are roots to the quadratic equation. We call them the zeros of the function, and they're also the x-intercepts on the graph. These four things are talking about the same value. They all mean the same thing, but it just depends on if I'm talking about the equation or the function and if I'm looking at the graph. So now we're going to be looking at the method of solving by factoring. So we're going to solve the quadratic equations by factoring. Now what we're going to be using is what's called the zero product property. Now you use this all the time, you just maybe don't realize it. So if I said 7b equals 0, what would b have to be? Well, something times b equals 0. Something times something is giving me 0, which means 7 is either 0, which we know it's not, right? Or b is 0, okay? So in this case, b would have to be 0. So anytime you multiply something times something else and get 0, either the first part is 0 or the second part is 0, right? So here, 5x equals 0. What does x have to be? Again, 5 can't be 0, so x has to be 0 here. So here's an example of a quadratic function and its graph. Where would the zeros be? Well, they would be at -1 and 5, right? So my solutions would be -1 and 5. Now we're going to look at the related quadratic equation, and we're going to see if we can get those same solutions. Well, if I factor this guy, remember how to factor? Factors of x squared go here and here, so that's x and x. Factors of 5 that will add or subtract to give me 4, that's 5 and 1. Different signs, biggest, product, negative. So I'm going to put a minus here and a plus here. Check my inners and outers, that's 1x. That is -5x. When I add them, I get -4x, so I know I did it correctly. So I want you to see what we have here. We have something times something equals 0, right? X plus 1 times x minus 5 equals 0. That means this quantity has to be 0 or this quantity has to be 0. So let's figure out what x value makes that 0. So either x plus 1 is 0 or x minus 5 is 0. Well, if x plus 1 equals 0, then x is negative 1. And if x minus 5 equals 0, then x is positive 5. So my solutions would be negative 1 and 5. Well, isn't that exactly what we got up here? Yes, these two things, these two methods gave me the same solution. All right, so here I've given you some quadratic equations that are already factored. So something times something equals 0, something times something equals 0. I've already factored them for you. And I want to figure out what the zeros or the solutions of the quadratic equation are. So we make our two little mini equations. Either this guy is 0 or this guy has to be 0. Well, if the first one's 0, solving for x, I'm going to get that x equals negative 7/3. Second one, solving for x, I get x equals negative 5. Therefore, my two solutions would be negative 5, negative 7/3. Okay, and you would plug those in, and you would see that if you plug them in, you get 0 equals 0 at the end of your problem. All right, over here, this guy either equals 0 or this one equals 0. So solving the first one here, x minus 8 equals 0, so x has to be 8. X plus 6 equals 0, so x has to be negative 6. So my solutions are negative 6, 8. We usually write our answer in ascending order, so smallest first and then largest. So there are the solutions to my quadratic equation. So if I graph these guys, I would get the same answer. Okay, so I need to factor this equation. Well, remember the first step to factoring is always GCF. I hope you remember that and ingrained it in your brain. Okay, so we always look for a GCF first. So here, my GCF is going to be 16x. Okay, so 48 divided by 16 leaves me with 3. And I'm taking out the x, so this x right here is no longer there. Minus 16x squared divided by 16x leaves me with 1x. And that's what I'm left with. So, something times something is giving me 0. So that means this something has to be 0 or this something has to be 0. So if 16x equals 0, well then obviously x has to be 0. And if 3 minus x equals 0, then that means I add x to both sides. X has to be positive 3. So my two solutions are 0, 3. Those are the solutions to my quadratic equation. So if you graphed this parabola, it would hit the x-axis at 0 and 3. Alright, so go ahead and factor these and then set each of your binomials or monomial to 0 and solve for x. Remember, all of your solutions should either be x equals something or x equals something, or you should have it in brackets separated by a comma.